Welcome, everyone. Today, we'll be discussing our research topic, downsampling and its various applications. Let's get started. Let me introduce our team, which consists of Edmund, Nigel, and Roy. Today, our presentation will cover four main topics. First, we will start by understanding the concept of downsampling. Then, we'll move on to discuss audio downsampling, followed by image downsampling. Finally, we will summarize our key points and conclude the presentation. So, what exactly is downsampling and why do we use it? Downsampling is the process of reducing the resolution or sampling rate of data. This technique is essential for optimizing speed and processing time, as well as conserving storage and memory. By reducing the amount of data, we can improve efficiency and manage resources more effectively. There are two main definitions for downsampling, which are image downsampling and audio downsampling. Image downsampling reduces the spatial resolution, number of pixels, of an image while maintaining its 2D representation. Audio downsampling samples an audio signal below the Nyquist rate, causing aliasing or distortion in the signals. Why do we use downsampling? There are several reasons. 1. To increase speed and processing time by reducing the bit rate for transmission over a band-limited channel. 2. To conserve storage and memory by decreasing the color depth and size of the image or audio file. 3. To enhance reusability and model adjustments by unifying data sources to the same frequency, allowing for model retraining without re-recording. 4. To improve procedural efficiency by eliminating unnecessary efforts like oversampling and speeding up calculations. Downsampling is sometimes unavoidable due to practical constraints. For example, it is essential for transmitting data over limited bandwidths and converting to more limited audio or image formats. A common example is WhatsApp, which reduces image quality by about 70% by default to ensure faster transmission. Now moving on to the audio downsampling. In this slide, we can observe the effects of audio downsampling. We compare the original sampling rate with a downsampled version to illustrate how downsampling impacts the audio signal. An anti-aliasing filter is a low-pass filter with a cutoff frequency, at most the Nyquist frequency. It prevents aliasing by controlling the frequency range. An anti-aliasing filter is a low-pass filter with a cutoff frequency, at most the Nyquist frequency. It prevents aliasing by controlling the frequency range. The audio downsampling process involves several steps. First, we sample the audio below or above the Nyquist frequency. Next, we use an anti-aliasing filter to control the frequency range. Then, we reconstruct the alias signal and calculate the sum of errors to reduce distortion and noise. This process ensures a higher quality downsampled audio signal. Downsampling involves reducing the sampling rate, while reconstruction includes downsampling the signal and applying anti-aliasing filters to reduce errors. This process helps maintain the integrity of the signal while reducing its size. Here, we compare downsampling with and without an anti-aliasing filter. The use of an anti-aliasing filter significantly improves the quality by reducing the sum of errors, demonstrating the importance of this step in the downsampling process. This slide shows the effectiveness of the anti-aliasing filter in noisy audio. The filter works better for noisy audio as it significantly reduces the sum of squared errors, highlighting its value in improving audio quality in various conditions. Let's look at the SWOT analysis for downsampling. Strengths: compresses and speeds up transmission of signals. Weaknesses: decreases quality of transmissions. Opportunities: enables fast and reliable data transmission. Threats: quality reduction can lead to illegible data. Downsampling has several real-life applications in audio processing. It is used for sending audio files over communication platforms, reducing noise in recordings and playbacks, and providing fast and reliable audio streaming services. These applications highlight the practical benefits of downsampling in everyday technology. Now, let's shift our focus to image downsampling. Here, we see an original image before any downsampling has been applied. This serves as a baseline to understand the effects of different downsampling methods. This slide demonstrates various methods of image downsampling and their effects on the image. By comparing the original and downsampled images, we can see how different techniques impact image quality. There are two primary methods for image downsampling. Method 1. The spacing method, which reduces the image resolution by skipping pixels. Method 2. The average method, which calculates the average color of a group of pixels to reduce the image size. Comparing the two methods, we find that Method 2 performs better mathematically by preserving more color information and depth. However, it may not always look better visually, as it can make edges more prominent and less smooth. Can we improve image downsampling further? By using anti-aliasing filters, we can enhance the downsampling process. Let's explore how these filters can be applied to achieve better results. There are several anti-aliasing methods available. 1. Supersample anti-aliasing. SSA renders the image in a higher resolution and then downsizes it. 2. Fast approximate anti-aliasing. FXA quickly smooths out jagged edges, but can make the entire image slightly blurry. 3. Temporal anti-aliasing. TXA combines several techniques for better smoothing, but is more demanding on resources. 4. Coverage sampling anti-aliasing, CSAA, and enhanced quality anti-aliasing, EQA. These methods offer advanced options for balancing performance and quality. The better the anti-aliasing filter, the more effectively we can downsample an image, resulting in smaller data sizes and faster processing speeds. This makes data handling more efficient and practical. This slide demonstrates the application of pixel coverage in the downsampling process. Effective pixel coverage helps in achieving better quality downsampled images. Image downsampling is widely used to save storage space, especially for high pixel density objects. It also reduces data size for transmission and enables faster processing on various devices, making it a crucial technique in modern digital imaging. In summary, we have discussed the concept of downsampling, its importance, and its applications in both audio and image processing. We also covered the role of anti-aliasing filters in enhancing downsampling quality. These techniques are essential for efficient data handling and improving overall performance. Thank you for your attention. We will now take questions from the audience.